awful lot of our understanding of the sky that we have kind of evolved into Western science through the Greeks. The Greeks were very good at trying to explain things and explain how things worked or how they thought that things worked. And so they were very practical in the use of astronomy. Astronomy was useful for navigation purposes. Remember, Greek islands, navigation, you have triremes, you have all these shipping going on. The problem that they had was if you sail out of sight of the coast, you could get lost at sea because it's very difficult to tell direction or what have you out on the ocean unless you understand the sky. And so understanding the sky was critical for understanding navigation. Well, the Greeks weren't just going to, the Greek philosophy was not going to just allow them to simply say, okay, let me describe how the sky looks. They wanted to describe why it looked that way. Why did things change in the sky? And so how does that help understand things? That was the Greek philosophy. And so they tried to understand it, and they said, well, it looks like the stars rise in the east and set in the west. The planets rise in the east and set in the west. And so they conceived of an idea. The moon rises in the east, sets in the west. The sun rises in the east, sets in the west. Everything does this. So they conceived of an idea in which the sun was the center of the earth was the center of the universe, and the sun, moon, planets all went around Earth, and then the stars went around Earth, and they all went around at slightly different rates, which is why the moon was lagging about a constellation behind every couple of days. It's the reason that Jupiter lagged behind about one constellation every year. It's the reason the sun shifted through the constellations. You know, this was their explanation, the whole thing. They have all these big crystal spheres slowly sliding past each other in harmony, and that gave rise to the sky that you see. Okay. So their idea was what we call the geocentric model, and that is that the Earth is the center of the universe. Okay. Now, interestingly enough, the book talks about the geocentric model in chapter 4, and then talks about some of the Greek work in chapter 3. So I'm taking this slightly out of order from the book. So the geocentric model in which everything goes around the Earth. Okay, and so even Pythagoras, you know, the guy that's been tormenting students with triangles, you know, for the last 2,500 years, he got into astronomy, and Pythagoras was saying, oh, the Earth is at the center because we don't really feel the Earth moving, unless maybe you live in California. You don't normally feel the Earth moving under your feet. And so he says, well, the Earth is sitting in the middle, and all the moons, planets, I mean, everything, sun goes around. Remember, they thought of the sun and the moon as fancy planets, and then all the stars go around. He figured out the moon doesn't actually shine. He figures out the moon is reflecting sunlight. Because the position of the moon in the sky was closely related to the seasons, or not to the seasons, but to the phase of the moon. And so he was able to say, well, it's always the side toward the sun that's lit up, so the moon's not shining, it's reflecting light. He was also able to figure out that the Earth was spherical in nature. And because that would explain why if you go to different latitudes, you see different stars overhead. And so that would work if Earth's surface is curved. And so that seemed to make sense to him. It also seemed to make sense from a geometric sort of thing, and that is if you got a ship and the ship is sailing along, that from a vantage point here looking off, you would only see the top of the ship, and when the ship got closer, you'd see the bottom of the ship. It sails away again, and only the mast is appearing. The higher you go, the farther you can see around the curvature of the Earth. So your vantage point, the higher you are, the farther you see. That only works on a curved surface. So he figures the Earth's surface is curved. And so this was one of the very first ideas. Aristotle comes along further, and he goes one step further and says, not only is Earth the center of the solar system, it's the center of the universe. We're the middle of everything. I know a lot of people that still think that. Okay. In fact, they think they're the middle of everything. He publishes a set of classic proofs that Earth is spherical. Not just round, but a sphere. And so he extends on Pythagoras' work. He does more along those lines. But he also says, wait a minute, the eclipses occur because the moon gets in front of the sun, or the Earth gets in front of the sun and blocks the light shining in the moon. So that would explain lunar eclipses. And he said every time this Earth's shadow hits the moon, it's got a round shape. There's only one shape that, no matter how light hits it, has a round shadow, and that's a sphere. And so he figures that Earth has got to be spherical. He also extends the idea that Pythagoras had, saying if you look from different latitudes, you see different stars going by overhead. He also used this because he said, well, the sun is out here in the space, and it shines on the Earth, and as the sun moves north and south, that places on Earth get the sun directly overhead, okay? But if you're too far north, it's never overhead, and too far south, it's never overhead. And again, that only works on a spherical planet. And so he has a set of proofs that the Earth is spherical. And so that the educated people knew the shape of the Earth in about 350 BC. And he also explained how eclipses worked and how lunar phases work. Aristarchus comes along, and he discovers an interesting sort of thing. He is trying to measure the moon, and he says, well, if you look at the moon, and you look at the moon 12 hours later as Earth moves, then the apparent position of the moon in the sky shifts a little bit. Okay, looks like it's here when you're over here, and when you're on the right over here, it looks like it's over here. By measuring that shift, you get a rough idea of how far the moon is away from Earth. And he figures the moon is roughly 30 times farther from Earth than Earth is across. Well, that's actually almost exactly right. Most people don't really get the Earth-Sun distance very accurately because you normally see it drawn wrong in textbooks. But if the Earth is like that, the moon is like way over here like that, a huge distance between the two. And so that's really, he was actually right about that. So he was right about the moon. Okay. He also went one step further, though, and he said, well, wait a minute. The phases, the first quarter occurs when the angle between the sun and the moon is right angles. The last quarter occurs when it's right angles. And he says, well, if the sun's up close, then it's going to be like that. And so this angle right here is going to be small. The farther away the sun is, the bigger that angle is. And so it turns out this angle between first quarter and last quarter is very close to 180 degrees. So he made a guess that the sun is about 100 times farther away than the moon. Well, it turns out it's actually about 400 times farther away. But he was on the right track that it's vastly farther away. But he also said the sun and the moon look the same size in the sky. And so if it's farther away, in order to look the same size, it has to be bigger. And so he says the sun has to be 100 times bigger than the moon. What's really vastly bigger than that. But that would make it bigger than Earth. And so he actually came up with the idea that maybe Earth actually goes around the sun instead of the sun around the moon. Because it made sense for the small thing to go around the big thing rather than the big thing around the small thing. And so this is what we call the heliocentric model. Now, there was a huge debate among philosophers at the time as to whether Aristarchus's heliocentric model or the previous existing geocentric model was the correct one. And they argued and argued and argued about that. And it took them a very long time, but they said, first of all, you don't really feel the Earth moving. It's not like a chariot driving down the road. You don't feel the Earth moving. And the other thing is, if Earth goes around the sun, that would make all the positions of the stars shift back and forth in the sky. And they looked and looked and looked, and they did not find that shift. Well, the reason they did not find the shift is the stars are really far away, and that shift is there, but that shift is about 4,000 times smaller than in 1 degree, and they did not have the instruments to measure anything that small. Another fellow we want to talk about here is Erastostones. Erastostones lived in Alexandria in Egypt, and he knew that at noon on the summer solstice, the sun was about 7 degrees south of overhead. But he also knew that in the village of Syene in southern Egypt, the sun was directly overhead at noon. And so he says, well, that means that if Earth is spherical, if straight up in Alexandria is here and the sun is 7 degrees to the south, but it's overhead there, that means the angle between the center of the Earth and Alexandria and the center of Earth and Syene is 7 degrees. 7 degrees is 1/51st of a circle. So he says, if you know the distance between Alexandria and Syene, that should be 1/51st of the circumference of the Earth. So what he does is he walks to Syene, measuring the distance, multiplies by 51, and he gets almost exactly the right size for the Earth. So let this sink in. We often think the ancients didn't understand a lot. And yet by 250 BC, we had Aristarchus saying, hey, I think the Earth goes around the sun. We have Aristotle saying this Earth is spherical. And we have Eratosthenes telling us how big it is. And they were all right. So this was actually all. So the question, therefore, is, what happened? How did this idea that they all had correct about the universe come to be wrong? In other words, why did they start thinking the Earth was flat? Okay, well, we'll get back to that. Okay. Part of it had to do with the fall of civilization, the barbarians invading, etc., etc., etc. But part of it is that a lot of people never did think the Earth was flat. That some of this knowledge hung around, and most of the educated people actually did know about the size and shape of the Earth. And so the idea that everybody thought the Earth was flat was really a myth, except for the uneducated people.